Friends, welcome to the class. Today we'll discuss about distance between any two points in a Cartesian plane. The distance between any two points in a Cartesian plane, say P x1 y1 and Q x2 y2, is given by PQ equals to x2 minus x1 whole square plus y2 minus y1 whole square whole root over. Or it can be written as x1 minus x2 whole square plus y1 minus y2 whole square whole root over. That means we can say the distance between any two points is nothing but square of the difference of abscissa plus square of the difference of coordinates whole root over. Let's see an example. Find the distance between the points P minus 6, 7 and Q minus 1, minus 5. So the given points are P minus 6, 7 and Q minus 1, 5. That means we can write it as we can treat that x1 equals to minus 6, y1 equals to 7, x2 equal to minus 1 and y2 equal to minus 5. So as per the given formula, PQ is nothing but x1 minus x2 whole square plus y1 minus y2 whole square whole root over. Now putting the respective values, we get PQ is nothing but minus 6 minus minus of 1 whole square plus 7 minus minus of 5 whole square whole root over, or it is nothing but minus 5 whole square plus 12 whole square whole root over, which is nothing but square root of 169, which is equals to 13 units. Hence, the distance between the given points is 13 units, is the answer. Find the distance between the point 3, minus 4 from the origin. That means the other point is 0 and 0. The coordinate of the other point is 0, 0 as origin. The coordinate of the origin is 0, 0. The given point, let this be x 3, minus 4 and y is 0, 0. Here x1 is 3, y1 is minus 4, x2 is 0 and y2 equals to 0. So now the distance between x and y is x1 minus x2 whole square plus y1 minus y2 whole square, or it is nothing but 3 minus 0 whole square plus minus 4 minus 0 whole square, which is nothing but square root of 25, or which is nothing but xy equals to 5. Thus the distance of the given points from the origin is 5 units, is the answer. If the distance between the points A 1, 1 and B x, 1 is 5 units, find the value of x. That means in this question the distance is already given, but we have to find the value of one of the origin. We have to find the coordinate of one of the point. So the given points are A 1, 1 and B x, 1, and the distance between them is 5 units. We know the distance between any two points is nothing but x2 minus x1 whole square plus y2 minus y whole square whole root over. So putting the values of x2 and x1, we can write it as AB equals to x minus 1 whole square plus 1 minus 1 whole square, or it is nothing but x minus 1 whole square plus 1 minus 1 whole square whole root over equals to 5, or it is nothing but x minus 1 whole square whole root over equals to 5. On squaring both sides, we get x minus 1 whole square equals to 5 square, which is equals to 25. Or on expanding, we get x square minus 2x plus 1 equals to 25, or it is x square minus 2x minus 24 equals to 0. On doing middle term factorization, we get x minus x 4 into x plus 4 equals to 0. Now you're getting both the factors x minus 6 and x plus 4 equals to 0, we get x equals to 6 or x equals to minus 4. Thus the record value of x is either 6 or minus 4, is the answer. Now we'll discuss about different problems related to distance formula. Problems on collinearity of points. If 3 or more points lie on the same line in a plane, then they are called collinear points. To check collinearity of 3 points, say A, B and C, we need to find AB, BC and AC. That means we need to find the distance between these 2 points A, AB, A and B, BC, B and C, and AC, A and C. If sum of any two shorter length is equal to larger length, then we can say that the points are collinear. That means if AB plus CB equals to AC, or if AC plus BC equals to AB, or if AC plus AB equals to BC, then we can say that the points A, B and C are collinear. Let's see an example. So that the points 3, 2, 4, 5/2 and 5, 3 are collinear. Let the given points be A 3, 2, B 4, 5/2 and C 5, 3. Now the distance between A and B, that means AB, is nothing but 4 minus 3 whole square plus 5/2 minus 2 whole square whole root over, or which is nothing but root 5/2. The distance between A and C, that means AC, is nothing but 5 minus 3 whole square plus 3 minus 2 whole square whole root over, or which is nothing but square root of 5. And distance between B and C, that means BC, is nothing but 5 minus 4 whole square plus 3 minus 5/2 whole square whole root over, or which is nothing but root 5/2. That means here it is clear, AB is root 5/2, BC is root 5/2, but AC is root 5. So now AB plus BC is nothing but AC. Hence the given points are collinear. Hence proved. Problems based on equidistant point. Let there be a point P on straight line AB which is at equidistance from A and B. To get the coordinates of P, we need to find AP and BP and solve AP equals to BP. Let's see through an example. Find a point on x-axis which is equidistant from the point 7, 6 and minus 3, 4. Let the given point be P 7, 6 and Q minus 3, 4. And AX, 0 is a point on x-axis which is equidistant from P and Q. So we can write AP equals to AQ. Now putting the distance formula, AP is nothing but x minus 7 whole square plus 0 minus 6 whole square whole root over, and AQ is x minus 3 whole square plus 0 minus 4 whole square whole root over. So on equating AP and AQ, we get x minus 7 whole square plus 36 whole root over is equals to x plus 3 whole square plus 16 whole root over, or x minus 7 whole square plus 36 equals to x plus 3 whole square plus 16, or on simplifying we get x square plus 14x plus 49 plus 36 equals to x square plus 6x plus 9 plus 16, or on cancellation of x square and on simplifying we get 20x equals to 60, or x equals to 3. Thus the point on x-axis is 3, 0 is the answer. Problems based on geometrical figure. Sometimes 3 or more points are given and we have to find the points constitute which particular geometrical figure. Let's see the example. Find out whether the given points form a triangle or not. If so, name the type of triangle so formed. And the points are 3, 2, minus 2, minus 3 and 2, 3. Let the given points be A 3, 2, B minus 2, minus 3 and C 2, 3. Now let's find the distance between the 3 points, that is AB, BC and AC. Now AB equals to 3 minus 2 whole square plus 2 minus 3 whole square whole root over, or what is nothing but 5 root 2, which is also equals to 7.07 unit approximately. BC equals to 2 minus 2 whole square plus 3 minus 3 whole square whole root over, or it is equals to square root of 52, or it is equals to 7.21 units approximately. And AC equals to 3 minus 2 whole square plus 2 minus 3 whole square, or it is equals to square root of 2, or we can say it is AC is approximately 1.41 unit. Thus the points A, B and C will form a triangle if the sum of any two sides is more than the third side. Here we have AB plus BC is greater than AC, AC plus BC greater than AB, and AC plus AB greater than BC. So we can say that these 3 points A, B and C constitute a triangle. Again, square root of 52 is nothing but square root of root 2 plus 5 root 2 whole square, or that means it is nothing but BC square equal to AC square plus AB square, which satisfies Pythagoras theorem. Hence triangle ABC form a right angle triangle with right angle at A is the answer. Let's see some more examples regarding this. So that the points A 2, minus 2, B 14, 10, C 11, 13 and D minus 1, 1 are the vertices of a rectangle. The given points are A 2, minus 2, B 14, 10, C 11, 13 and D minus 1, minus 1, 1. So AB is 14 minus 2 whole square plus 10 minus 2 whole square whole root over, or AB is nothing but 12 root 2. BC equals to 14 minus 11 whole square plus 10 minus 13 whole square whole root over, or written nothing but 3 root 2. CD equals to 11 minus 1 whole square plus 13 minus 1 whole square, or written nothing but 12 root 2. AD equals to 2 minus 1 whole square plus minus 1 minus 1 whole minus 2 minus 1 whole square whole root over, written as 3 root 2. AC equals to 11 minus 2 whole square plus 13 minus 2 whole square whole root over, what is 3 root 34, and BD equals to 14 minus 1 whole square plus 10 minus 1 whole square whole root over, or it is also equals to 3 root 34. So the given quadrilateral ABCD, the opposite sides are equal, that means AB equals to CD, AD equal to BC, and also the diagonals are equal, that means AD AC equals to BD. Hence, it is proved that the quadrilateral so formed is a rectangle. If ax, y is a point lie on the line joining b2, minus 3 and c minus 4, 5, and a is equidistant from b and c, prove that 3x minus 4y plus 7 equals to 0. Given that the points ax, y, b2, minus 3 and c minus 4, 5 lie on the same straight line, and a is equidistant from b and c, that means we can write ab equals to ac. Now, ab equals to ac can be written as x minus 2 whole square plus y minus 3 whole square whole root over equals to x minus 4 whole square plus y minus 5 whole square whole root over, or removing the square root on both the sides, we can write it as x minus 2 whole square plus y plus 3 whole square equals to x plus 4 whole square plus y minus 5 whole square. On expanding the square factor, we get x square minus 4x plus 4 plus y square plus 6y plus 9 equals to x square plus 8x plus 16 plus y square minus 10y plus 25. Now, cancelling x square and y square on both the sides, we get minus 4x plus 6y plus 13 equals to 8x minus 10y plus 41. Or on simplifying, we get 12x minus 16y plus 28 equals to 0. On dividing by 4 on both the sides, we get 3x minus 4y plus 7 equals to 0. Hence proved. Point A minus 1, y and B 5, 7 lie on a circle with center O 2, minus 3y. Find the value of y and the radius of the circle. Given that the points A minus 1, y and B 5, 7 lie on a circle and the center of the circle is O 2, minus 3y. So we can write y equals to OB, which is nothing but radius of the circle. Now y equals to OB can be written as 2 minus 1 whole square plus minus 3y minus y whole square whole root over plus 5 minus 2 whole square plus 7 minus 3y whole square whole root over. Now removing the square root on both the sides, we get 3 square plus 4y square equal to 3 square plus 7 plus 3y whole square. Or on simplifying, we get y square minus 6y minus 7 equals to 0. Or doing the middle term factorization, we get y plus 1 whole into y minus 7 equals to 0. That means y equal to either minus 1 or y equal to 7. Taking y equals to 7, we get the radius of the circle OA is nothing but 3 square plus 4y square, or which is nothing but 3 square plus 4 into 7 whole square, or which is nothing but square root of 793 unit. Thus the value of y is 7 and the radius of the circle is square root of 793 units is the answer. Here we saw a few examples. we practice few questions. The more and more such questions we practice, the easier it becomes and the more you like it. So friends, do practice more and more such questions, and in case you come across any difficult questions, feel free to share your question with me. It will be a pleasure for me if I can help you out in solving your doubts and solving your questions. So this much for today's class. Thank you.